All right, guys, so let's talk about those proportional relationships that we already discussed here. So let's take a look at those and see what our constant of proportionality was. We sort of talked about this in the last video, right? So one thing I do want to note is, tables are going to be shown in different ways. These are vertical tables, horizontal tables. You are going to have to be able to find your constant proportionality regardless of the type of table. You're also going to have to be able to determine whether something is proportional regardless of the type of table. So if a table is horizontal like this, usually the x value is on top and the y value is on bottom. Okay. And if it is a table like the ones previous, then those were already labeled, but usually the x is on the left and the y is on the right. Okay, so what is our constant proportionality here? We found out in the first video how to sort of figure that out based on the word problem, based on the table, but let's find it out using this equation here that we just learned, this y equals kx. Let's see if we can solve for k, given that we already have a y and an x value. Okay, so I do have any y's and x's here. I can choose any ordered pair. I'm going to choose this one just because why not? It's in the middle of the table. It might be a nice pair to try. So we're going to try to find k, taking the data point 3, 9 and solving for k. So let's label this really quick. Remember, the first value in a coordinate is the x value. The second one is the y value. So when I'm substituting here, I'm going to want to make sure that I substitute the right way. So I'm going to rewrite my equation first. It's always nice to just write the equation before you substitute anything. We do like to put parentheses when we substitute just in case, because it can get confusing at times. All right, so I'm just substituting in here. I'm putting my 9 in for y. I'm putting my 3 in for x. Okay, what I'm noticing here is if I rewrite this and realize that the parentheses in this case are not necessary anymore and I can drop them, the reason why is because right here, nothing's happening with this 9. It's just a 9, right? So parentheses here, they don't change anything. I can drop it, make it look easier. Over here, this is k times 3, right? Well, that's the same thing as 3k. So we can rewrite that without the parentheses, and I'm going to show you why we would do that, because it's actually going to look a lot easier than it does over here. So over here, it looked real complicated. Here, it's looking very easy. If you think about just going back to last unit, when we're solving two-step equations, say I'm solving a two-step equation, I did my first step, I added something on both sides, whatever, and I got to something like this. This is like the last step in a two-step equation, okay? It's like the last step. And remember, we always sort of assume, unless it looks different, that our last step in a two-step equation is to divide by the number that's next to the variable. Now, this is not always the case, but it is the majority of the time going to be the case. So all that said, basically what I'm trying to tell you guys is, in order to find k, we have to divide by 3. And the reason why is because I have this 3 times k. Remember, I want k equals something. I'm trying to find k. We already sort of think that it's 3 based on what we talked about in the first video at the beginning of the lesson, right? We said that this is $3 per day. So it makes sense that our ratio, our constant proportionality, our unit rate is 3, okay? But we're trying to use this algebraic way to make sure that it is 3. So dividing by 3 on both sides will get rid of this 3 here, and I'm just going to isolate it so that now I just have a k, which is what I wanted, right? So 3 divided by 3 is just 1k, or just k, right? So this is technically a 1k, but we don't put that 1 because it's invisible. We don't need it. And 9 divided by 3 is 3. So in this case, we did find k to equal 3, which makes sense. That is our multiplier. Remember, k is that constant of proportionality, that multiplier that tells us what do we do to the x's in order to get to the y's. We can check that just to make sure. Well, if I took 4 and multiplied it by my multiplier, my k here, 4 times 3, that would give me 12. Well, that makes sense because my y is 12, right? So like you're saying, does it make sense that that would be the constant proportionality? Yes, okay, it makes total sense. This is the $3 per day. That's our ratio. That's our constant proportionality. All right, you guys are going to try this one on your own. What is the constant proportionality for this previous table that we looked at? I want you to solve it in terms of y equals kx. So you're going to take one of these points you choose. You're going to plug in the x value for x. You're going to plug in the y value for y. You're going to simplify this and find k. Then you're going to determine whether that k makes sense based on the rest of the points in the table. All right, so you guys are going to get a chance on that, and I'll see you in the next video.